Good afternoon, flippers. Our video today is 3.3. Our unit title is Stop Motion Animation, and our objective is I can identify properties of centroids and incenters. Our IXL skills are the same as before. So, to understand really incenters and centroids, we need to understand points of concurrency. And I know we talked about them in a video before, but we need to review them. A point of concurrency is where multiple lines meet or where they intersect. And we call that point of intersection a point of concurrency. Something that wouldn't be a point of concurrency would be three or more lines that don't all intersect at the same place. And you can see there's a gap between them. The two special types of concurrency we will look at today are incenters and centroids. Incenters we create on a triangle with angle bisectors. So I'm going to draw 3 angle bisectors because they split each of my angles in half. Where those 3 angle bisectors meet is the point of concurrency, and when it is angle bisectors that we're talking about, they are called incenters. So when we have a point of concurrency created by angle bisectors, we call that an incenter. The special properties of incenters are that they're equidistant to the sides. So that means they're of equal distance to the side of the triangle. I know that because my incenter is created by the angle bisectors, and we know that angle bisectors cut an angle perfectly in half, so it has to be equidistant from the two sides. Moving on to the end circle, that is then just the largest circle that will fit inside the triangle and touch all 3 sides, and its center is the incenter. Moving on to centroids, which are created by medians. So our medians create our centroids. Our medians are just the lines or a line segment that comes out from the vertex of our triangle and make cuts at the midpoint of the opposite side. So instead of being an angle bisector that cuts the angle perfectly in half like we have here, it cuts the line segment on the opposite side perfectly in half. The centroid then is that spot where all 3 medians intersect, where they all intersect or are concurrent. And we call that the centroid. Some properties of centroids. The distance from the vertex to the centroid is 2/3 of the total median. So if this is our median, because it's the line coming out from the vertex and cutting our line segment perfectly in half, then the part from the line segment cut in half to the centroid is exactly 1/3 of the total length. And then this part from the vertex of our angle to the centroid would have to be 2/3 of our total length. And this is true for each one of our medians, thus dividing the median into a 2-to-1 ratio. Example 1. The vertices of the triangle in the diagram below are A, 7, 9, B, 3, 3, and C, 11, 3. What are the coordinates of the centroid of triangle ABC? Well, we know the centroid is created by our medians, which cut the sides in half but aren't going through the angle bisectors. So there's 2 ways I can solve this. I can solve it using my distance formula to get the distance of each of my side lengths, here, here, and here, because the distance formula gives you the distance between 2 points, or because this is on a graph, I can count, which is what I did. So what I already have shown here is I counted up, and it's a little hard to see here, but if you had it on paper, you could see it. It goes 1, 2, 3. And from this side, it goes 1, 2, 3. So this is the middle of this line. And then I did the same thing on this side. 1, 2, 3, 1, 2, 3. And then I did it down here, which is much easier. And it actually is 1, 2, 3, 4. 1, 2, 3, 4. And I go up here. And then I labeled. So I came down, I drew my line here. So where they all connected, I drew my line down here, which shows my x coordinate, which is at 7. And I drew my line out to my y. And I saw that it intercepted my y at y equals 5. So the coordinate point of my center point was 7, 5, or answer number 3. Sorry, I just want to correct that real fast. You would not use the distance formula. You would actually use the midpoint formula to find the midpoint of these 2 points. And to make it up to you guys, I put the formula right here. So you should pause and write it down right now. The second question shows you a diagram and asks you what point of concurrency is shown above. What point of concurrency where all the lines meet is right here. Well, what we've learned is it could be an incenter or it could be a centroid. Which one is it? Well, we know that centroids are formed by medians. And looking here, we know that medians are created by lines intersecting the side length and creating bisecting it to create 2 equal halves. And that's what we have right here. We have 3 medians that intersect the sides to create equal halves. So we know that it must therefore be a centroid, because that is the point of concurrency created by these medians. Well, what is it formed by? We've essentially already answered that. We've looked at these lines, and we've decided, hey, they're coming out of the vertices, and they're intersecting this side halfway, so we have 2 equal, and it's perpendicularly bisecting, or not perpendicularly, but it is bisecting this side. So therefore, these must be medians. Centroids are always formed by medians. So now it is time for the secret hot question. 4. In the diagram below of triangle ABC, line segment AE is congruent to line segment BE here, and line segment AF is congruent to line segment CF, and line segment CD is congruent to line segment BD. Point P must be and you have these options here that we've learned about. So some of these you might know, but you definitely know some of the options listed here. So look back at your notes and make sure that tomorrow when you come in, you have the picture drawn. And that also you remember that you have a quiz coming up. So start this unit strong. See you tomorrow.